I'd like to introduce our next speaker. It's Dr. Charles Chan from the Open Networking Foundation. Now, these are one of those organizations that I know we talked about quite a bit in the MyTech presentation. We talked about it in the Delta presentation. There was a lot going on, and I know George will also be talking about it later on this afternoon. Charles is the system architect and has done a lot here with software for SEBA and Trellis. He's also part of a program called the Ambassador Program in Taiwan, and he'll talk a little bit more about what that program is. Please help me welcome Dr. Charles Chan from Open Networking Foundation.
Thank you, Ursula, for the introduction. Hi, everyone. Charles Chan from Open Networking Foundation. And today I'm going to talk about how we enable telco edge cloud with open source software and disaggregated hardware at ONF. So first to begin with, I would like to talk a little bit about what exactly ONF is and what we're doing at ONF. So ONF is a operator-led consortium. We're, our top tier members are mostly telco operators. You can see a lot of very familiar names here. So these operators are, all of them are seeing a common problem, which is they need a cloud-like economies and agility, but incumbent vendors have not been really providing these open tools and cloud-like building blocks for them. So they actually come together and join ONF to collaborate on the projects and trying to address these common problem. So ONF Mission, what we're trying to do at ONF is that we're trying to transform operator networks and bring CapEx and OpEx efficiencies to the service providers and try to enable innovative services. So how we do that, we actually have three major technologies we adopt to achieve that. The first one is open source software. And then the second one, which is more related to OCP event today, is open and disaggregated hardware. And then we also use a lot of cloud-native technologies to achieve that. So this is how our ONF membership pyramid look like. So on the top tier, you're going to see a lot of, I hope the logo is large enough for the people in the back. You're going to see a tier one, service providers in the top tier, and then followed by also the vendor partners. You can see a lot of them. EdgeCore is one of them. George is going to talk about that after this talk. And we also follow that. We also have a few, innovator service providers. We also have more than 70 innovative vendors and also more than 70 collaborators. So on the right-hand side, you can see these are the members on the ONF board. You can see most of them are actually very high-level executives from service providers. And this one, I made this especially for this event because I want to talk a little bit about our community here in Taiwan. So at the top level and the partner level, we have EdgeCore, which we really appreciate the support from EdgeCore. And then we also have a second tier, which is the collaborating innovator. We have QCT, Inventec, Delta, and Linker Networks. And then we also have innovators like WeWin and Nefis. We also have several collaborators like SDNet, Netberg, National Jiao Tong University, and National Zhongzhen University. And then we're also exploring collaboration opportunities with MyTech and Zhonghua Telecom at this moment. And of course, Arshana mentioned about this ambassador program. So basically, ONF is based in Silicon Valley, United States. We don't have much footprint, elsewhere in the world. So we started this ambassador program to have local representations who can actually talk about ONF stuff, in the community. So I'm leading the ambassador community here in Taiwan, and then we also have 4 other active ambassadors in Taiwan. So what we're doing at ONF, we're doing in a pretty special way. We call it operator-led curated open source community. What that means is actually the operator will start and prioritize their use cases, right? Operator will first agree on the common use cases they jointly want to pursue, and then the operators will also commit to trials or deployment. And then the ONF lab will come in. So this is also very special that we actually have engineering team that it's not very big. We have like probably 20 people. This team is usually described as small and mighty, and it's independent engineering team, not, it's not coming from other vendors, incumbent vendors, such that we can dedicate to this mission and with no legacy to protect. And then once we come up with this, the software implementation, we have this, what we call Curated ecosystem develops. We curate a supply chain partners, and kind of ask them to engage with this community. We all invite these, ODMs and vendors who's aligned with the mission we're trying to pursue. And the operator, the commitment coming from the operator will make sure their ROI. And also, we have more than 7 years of experience working with operator partners. So this is how our ecosystem works. So most of the requirement coming from operator, we're very operator oriented, and we follow requirement and build the building block and kind of having this feedback and build this ecosystem. So we have a very special strategy too at ONF. We call it reference design strategy. So right here you can see this is like a typical open source project pipeline you're going to see. So first of all, you're going to see open source component over here, and then as the open source program grow and become more mature, it's going to become an example platform, and it will eventually some company will adopt that and build a commercial solutions, right? And then this solution will be taken by the operators into trials and then eventually production deployment. This is pretty typical. So this is how we use open source. What's special about ONF is that we also take this open source component, and then on top of it, we build something called reference design. Reference design is, you can consider that as a software-defined spec that operator agree on, that this is the requirement it should be. And then also, this requirement is not just a document that get released once and never change after that. We have this feedback cycle that this reference design actually is going to affect the exemplar platform, which is also going to feedback back to the open source component, and open source component is going to feedback into the reference design. So we're going to go through this kind of cycle, several rounds, and then eventually produce a solution, and then bring it into trials and deployment. And as you can see, this reference design will eventually become what people are more familiar is called RFP. It's like a golden standard for this RFP. So why is ONF so different, and how is it different from other initiatives? So first of all, as I mentioned several times, that we are very unique because we are operator-led, curated open source model. And we are an open source organization with an engineering team, which is actually not very common if you look at other open source projects, right? So our lab, ONF lab, enables and accelerates the implementation of the things we're trying to pursue, and then we can do that in a very disruptive way. Without without the resistance from the incumbent vendors. So we're driving disruptions. It's very essential at the access and the edge, because a lot of service providers already identified that the major CapEx costs are actually happening at the operator edge. So we're trying to address the the most critical part of service providers need. So now I'm going to talk about what solution we have. So if you can consider, on the left-hand side is closer to the customer, you're going to have access technologies, and then of course you're going to have an edge cloud over here, and then behind that you're going to have a core infrastructure. So we kind of categorize our solution as two kinds. So one is for broadband and fixed networks, and then another one is for mobile. And then of course, in order to support these two use cases, we need to have a common SDN infrastructure. So for that, we started with OpenFlow, which is actually a control protocol for the SDN controller to control the switches and devices. We have ONF as our SDN controller. ONF is of course open source. And then on top of it would be a project called Trellis. It's our NFV fabric and SDN backhaul. And Trellis is the project I'm mainly involved in. I'm a lead developer of Trellis. And then on top of this infrastructure, we build two use cases. Core is stand for central office re-architected as data center. So we have a residential version. You can consider it as a different profile. We have a residential profile and a mobile profile. So the residential profile then gets split into two parts. So we have a project called VOLTHA. It focuses on how to disaggregate the OLT optical line terminator. So VOLTHA project is more focused on the access and OLT disaggregation. And then at the edge, we have something called SEBA. It's SDN-enabled broadband access. Basically use a lot of SDN technologies to kind of reinvent the ways we would deal with broadband and enables the service providers to introduce more innovative services in the edge. Of course, in M-Core, we have a similar thing. So we have, on the access side, we have ORAN. ORAN is not, if you strictly speaking, is not under ONF at this moment, but we collaborate a lot with them. So ORAN is about the mobile access technology, radio access network. And then on the edge side, we have a project called OMAC. It's basically an open mobile EPC. And of course, in order to interconnect multiple edges, you need a transport network. So here we have something called ODTN, is a disaggregated optical transport project. And then on the controller and infrastructure side, we're trying to migrate to something we call next generation SDN. For ONF, it's going to we're trying to migrate to micro ONF. It basically introduces the idea of microservice and device config management and operation capabilities. And it's pretty similar on OpenFlow. We're trying to migrate to Stratum and P4, which also, in addition to just program those devices, we introduce the capability of device config management and operation. And then we also have a pretty big umbrella project called COMAC. It's converged multi-access and core. So basically, in COMAC, it has both access and edge technologies for both mobile and broadband. And this is ONF in context of other open source ecosystem. I think Hancock showed this a very similar diagram this morning. This is what we're doing at ONF. So we focus on access and edge and also next generation SDN. And of course, we collaborate a lot with OCP. We benefit a lot from the OCP program. We get all our hardware peripherals from OCP data center devices. We also collaborate with another organization called TIP. We have specialized telecom devices from TIP as well. We also use a lot of open source software from other communities like Kubernetes, and the software from a cloud native foundation, and it was a Crano. On the top, we can also kind of connect our stuff to the end-to-end orchestration system like ONAP and OSAM. On the right-hand side, we also collaborate with several standards like MEC and ORAN. And by collaborating with other open source communities, that enables us to provide something from white box peripherals to end-to-end solutions. So this is the status of each of our projects. Trellis and Honest, again, they're SDN leaf-spine fabric. They're already in production with a tier 1 service provider in the United States, with thousands of subscribers, by the way. And we have SEBA. SEBA is also in a significant trial with AT&T, Deutsche Telekom, Turk Telekom, Telefonica, and a lot of other providers are interested in looking into SEBA. For ODTN, we also have lab trial with NTT Communication, Telefonica, and Telecom Italia. And Stratum and NG-SDN Stratum is actually a project started by Google, so Google already used that in production in their network at scale. So COMAC and OMAC is just getting started. It's newer compared to other programs, but we also have Sprint and DC doing field trials. And CORE is kind of a big umbrella project that covers all of these. So what we're trying to do is we're disrupting a 300 billion market. If you look at the operator capex over here, they have 350 billion plus capex cost. And then if you look at it in detail, you'll notice that most of them are actually spent at the edge. So this is what we're trying to do. So this is the cost. So typically, the operator will buy a big black box devices from incumbent vendor, legacy devices. You have some spend on the software and hardware. You don't actually know the ratio because they are sold as a package from the incumbent vendors. But what we're trying to do is that we're trying to introduce open source software to reduce the cost of this part. And then we also introduce the open disaggregated hardware, so reduce this cost significantly as well. But the overall spending is actually not decreasing. What we're trying to do is we are trying to reallocate the resource. So now you have some extra resources here. The telco operators can do innovative services and differentiated services over here with this money over here. So that enables service provider to differentiate their stuff with other providers. Again, we have operator traction worldwide. I'm just not going to go through all of them. But these two, these two are coming from the community. People say that nearly 40% of all end customer will have service provided by some form of cord by 2021, and 70% of the operators worldwide are planning to deploy cord. So how ONF benefit from OCP? So I'm going to start with a project called VOLTHA. VOLTHA stands for Virtual OLT Hardware Abstraction. It's our OLT Disaggregation program. So what we're trying to do is that this is the typical OLT you're going to see in a telco central office. It's a pretty big box. It's like the blade design. You have palm blades, you have compute blades, you have a backbone that connect all of them. So we're trying to transform this one into an open disaggregated solution. So on the right-hand side, you can see VOLTHA project. We actually implement an open OLT adapter that can actually talk to a white box XGS PON OLT. Of course, this is OCP accepted device. And in this device, we run open OLT drivers, and that programs the device going through a certain SDK. And on the northbound, we connect this VOLTHA to our SDN controller, so it's actually centralized control. And on top of that, we run services like VLAN configuration, AAA service, multicast service, and etc. The next one is Trellis plus NG-SDN. So Trellis is our leaf-spine fabric, and we also introduced some NG-SDN technologies into Trellis to form a next-generation networking fabric. So this is like a typical leaf-spine you can see. So also we have on us as our SDN controller that controls all of them. We run the Trellis apps that provide features like IPv4 and v6 unicast, multicast, VLAN, MPLS, second routing, blah, blah, blah. And of course, the leaf and spine switches we're using here are both open accepted, OCP accepted devices. And the reason I use different colors over here, red and blue, is because we actually support two different kind of devices. On the right-hand side is the more people will think about SDN. It runs OpenFlow protocol. You're going to have an OpenFlow agent on the box, and it talks to the, for example, if you use Broadcom chip, it talks to Broadcom OCP and talk to the SDK to program the device. But on the right-hand side is what we call next generation SDN. We're trying to build something called Stratum. Stratum is a thin switch OS that actually unify the interface on the northbound, and it also has drivers and that can talk to different devices. So on the northbound we have P4 runtime for flow programming, we have GNMI for device management, and we have GNOI for operation. These are all standard interface that's well adopted by Google. And by the way, these two types of devices are also both open OCP accepted. And by the way, if you notice that we use exactly the same application on the top without any modification on two different type of devices with very different software stack over here, because we have a very good abstraction at this layer. And then SEBA is kind of a combination of the above mentioned programs. So if you look at this, the left-hand side is actually the VOLTHA project. So we have several OLT over here that further connect to the residential subscribers. We also have a leaf-spine fabric. This is our Trellis program. And then also we attach several servers. These servers are OCP inspired. These can provide services and compute resources if we want to run some service to serve these customers. And on the top, these are all controlled by the same SDN controller on us. And then in on us, we run several different kinds of apps. We have AAA, VOLTHA, and DOCP. I'm just not going to go through all of them. And we also use Docker, Kubernetes, and Helm as to build our stuff. On the northbound, you can see what we call network edge mediator. It opens an API that allows you to attach the system to your OSS, BSS, or other kind of orchestration system like ONAP. And on the right-hand side, this will connect to your upstream and core routers. So, quick summary. ONF, we are an organization that's operator-driven, curated open source. We enable telco edge cloud with three key technologies: open source software, disaggregated hardware, and cloud technologies. So core central office re-architected as a data center is our flagship umbrella project that covers almost everything. And then under that we have SEBA. SEBA is SDN enabled broadband access built on the core platform. We have several modular components. VOLTHA is it abstracted the PON as similar to an Ethernet switch to the SDN controller. Trellis it manages multi-purpose leaf-spine fabric. And then we also have next-gen SDN that enables innovative services with programmable pipeline and unified interface. And most importantly, all these projects I mentioned benefit from OCP hardware. And this is how, if you're interested, this is how you can get involved. You can go to our website, opennetworking.org. You will find all the information, all the detail about the program we're doing and our kind of involvement, the telco involvement. We're going to have a annual event called OCP Connect 2019. We will have that this September from 10th to 13th in Santa Clara, California. The CFP is still open, but not for long. It's still open for until tomorrow. But if you're involved in this work, you're welcome to take 15 minutes. We only ask you to submit an abstract. You can get involved and get a free speaker ticket. Or if you just want to join as an audience, the registration is open too. So you can visit this website to know more about this. And then also, as a lot of people already mentioned, that there is a task force in OCP that's specifically focused on telcos. It's called Open Edge. So if you want to learn more about that, you can go to this website. That's all about my talk. Thank you.